A motorcycle with no way to get the power from the engine to the wheel won't go very far. Welcome to the Throttle and Roast podcast. I'm your host, Niels Meersschaert. In today's episode, I'll cover the types of drivetrains that you may find on motorcycles ranging from chains to belts and even shafts. Why is there variety on these drivetrains, and is one better than the other? And what kind of bikes benefit from each of these different drivetrains? So we're going to start with what's probably the most common type of drivetrain that you'll find on motorcycles, and this is the chain drive. And fundamentally, what this is doing is that the output from the transmission of the motorcycle is running effectively perpendicularly to the bike. And this rotation then allows a sprocket to be placed right on the output shaft. And then that is connected via a chain to another sprocket that's on the rear wheel. And as this sprocket rotates, it's going to transfer the power from that transmission and thus from the engine to the wheel through the chain. Now, the chain has multiple links that are connecting these two sprockets, and this allows the chain to flex a little bit. It doesn't have to be a rigid driveline. It can have a little bit of flex. And typically, what you're going to have on most motorcycles is you're going to have a swing arm so that the rear wheel can actually move with some suspension. Therefore, you can't have that rigid driveline because it would just lock up. The driveline itself would prevent the suspension from moving. So having this allows the motorcycle to have that transmission of power, but allowing a little bit of fluctuation of exactly how that driveline is going. And if you have a bicycle, this is going to look very, very familiar. In fact, you could think of it as exactly like a bicycle chain with the sprockets in the front that's on your drive or your pedal wheel, and the sprockets that'll be on the rear of the particular bike. It's just sort of supersized, and that's really the fundamental difference. Now, the other cool thing about a chain drive is that the ratio for the final drive is determined by the number of teeth on the wheel sprocket divided by the number of teeth on the sprocket on the transmission. And this way, you can actually change those sprockets to create a different final drive ratio. So when a manufacturer is putting together a bike, they may have whatever they've put in for the engine power. They may have adjusted some things into the transmission. Well, they're going to be able to tweak that a little further with what they select for the final drive. Now, there are a couple of variations when you start to think of the particular chains. And if you really think of the oldest motorcycles, they're going to have a variety of chain that really you don't see anymore. And this is where it's an unsealed chain. Fundamentally, there's nothing in the chain that is holding the lubrication in place. There's nothing that's really making it as robust or durable as it would be otherwise. And this is just how chains really started off. The one that you're going to probably see the most commonly, though, is going to be with O-rings. And essentially, these little rings that are literally shaped like O's, thus the name, they are used to keep lubrication on each one of the links. And they're very commonly found on dirt bikes because this is where you really fundamentally want to make sure that you have that lubrication, that you're not allowing dirt to get into the various elements of each one of these links and therefore start to create a little bit of a grit or grind that's going to wear the chain prematurely, as well as potentially to lock it up and prevent it from being able to move and flex very easily. Now, another variation that you might see is an X ring. And again, this is going to be just like what the ring itself looks like. These X's are going to be a little bit more efficient than an O-ring, and therefore they're often used on high performance motorcycles. So if you look at most sports bikes, you're going to find that they're going to have X rings on those particular chains. And this is just going to allow them to be a little bit more efficient in how they're able to deliver power. So what are some of the pros of a chain drive? Well, the biggest one is efficiency. In fact, they're about 98% efficient in terms of transferring power from that output shaft of the transmission to the rear wheel. So if you're really trying to have high performance, this is going to make sense for why you would want to use a chain. The other advantage is that they are very low cost. It keeps bike prices lower and it reduces the replacement cost because this is a wear item. This is something that you do need to replace periodically, but because it's relatively low cost, it's not going to cost an arm and a leg to replace that chain and the sprockets when it's necessary. It tends to be the most popular because it has all these really positive attributes. And I touched on it a little bit earlier, which is that you have that final drive ratio. Well, this actually allows you to change the final drive ratio. And you'll see a lot of people will do this, especially on dirt bikes, where you'll change your sprockets either on the front sprocket or more commonly on the wheel sprocket, just to add or subtract a couple of teeth. And this will allow you to get to the point where you have a little bit better acceleration or you have a little bit better top end, and therefore be able to tune the bike to your needs as you wish. But like everything in motorcycling and pretty much in life, there are cons to chains. And probably the biggest con, the one that personally for me is a real frustration with them, is that they have such frequent maintenance requirements. In fact, every few hundred miles, you really should be cleaning first and then lubing the chain. The idea behind this is just in the normal course of riding, there's going to be some contamination that gets into the chain. And this could be coming from your brakes, some brake dust could get in there. It could be just normal dust and road grime that's going to get into the chain. You could have ridden through dusty conditions and then that got onto the chain. So to maximize the longevity of the chain, you do want to clean it every few hundred miles and re-lubricate it. And the lubrication is really critical. So even if you want to maybe not bother with the cleaning, you'll at the very least re-lubricate it and keep that chain going. Now, there are some devices like a Scott oiler, which is a kind of an automated oiler that a lot of people will put, especially on dirt bikes, that will just automatically drip some lubrication onto the chain in a very limited sort of manner. So it's going to effectively give you what you would add in the course of that few hundred miles. It's going to ease that out over those couple hundred miles. So it's a very slow flow. And this does make it a little bit easier because you don't then have to stop and remember to re-lubricate your chain. So that's the biggest con, I'd say, is the frequent maintenance. The second one is chains can stretch over time. It's not like a rubber band. It's not that, hey, it's stretching just because there's some elasticity built into the chain. It's really more fundamentally of each one of these links is really, it's a pin with a couple of side rivets. And eventually what happens is that just from normal usage and, you're going to pull on the chain and to accelerate, you're going to then have some retarding as it's slowing down with engine braking. So this is just going to eventually just grow the holes where those pins are going through the side panels just to make them a little bit larger over time as it just continues to wear in. And as a result, because of that elongation of those holes, the chain itself now can pull a little bit further apart, and therefore the chain's overall length grows. And because of that, the position of the chain on the rear wheel is going to need to be adjusted. Otherwise, the tension is not going to be correct. So if you look on most swing arms for a chain motorcycle, there's going to be a couple of bolts that'll be on either side of the wheel. You'll loosen those up, and then you'll have typically some indicators so you can kind of have a relative line of where your current position of the wheel within the swing arm is. And then you can move it in or out as appropriate just to get that chain tension back to what it needs to be. So every few hundred miles, every 1,000 miles, whatever it ends up being, you're going to need to just check that you have the proper chain position and then adjust it as necessary. Now, another one of the cons, of course, is that they can have noise, vibrations, even some chain slap can happen. So it can be a little bit noisier as you're riding along just by virtue of having that chain out there. It's metal against metal, so it's going to be making a decent amount of noise, and this can be maybe a little fatiguing for some people. So it's not I'm not trying to make it where it's louder than, let's say, the engine or the exhaust would be, but it is another add-on to noise that the motorcycle is making. The other thing, and this is where even though chains are fairly durable, and as I mentioned that they're low cost, they do have, out of all of the drivetrains that we're going to be talking about today, they have the shortest lifespan. And this means you're typically going to need to replace the chain and the sprockets somewhere between 15 and 30,000 miles is usually about where it ends up, assuming you've been doing the maintenance correctly. If you have not been cleaning and lubing that chain, you may need to replace these far earlier. The other thing is if you're riding in dirt, of course, where you're going to have all of those contaminants getting in there more commonly, this is going to accelerate that wear and you may need to replace it even earlier than that. But for street motorcycles, typically between 15 and 30,000 miles is usually the lifespan. The thing also is you're not just replacing the chain, you're also replacing the sprockets. And the reason for this is that all three of these items, the front sprocket, the rear sprocket, and the chain, are wearing and wearing together. And if you think of the sprockets, they're effectively some teeth. You could think of them almost like a sort of a triangle. Well, that triangle is going to eventually kind of curve towards one side as just the normal wear and tear on that chain and the sprockets occurs. And therefore, if you were to then just replace the chain, what's going to happen is that the chain will quickly adapt to the shape of the sprocket nets now, and you're actually going to accelerate the wear. So you're replacing all of them at once. This is going to give you the maximum amount of longevity. Now, typical applications for where you're going to see this, as I said, dirt bikes is going to be, I don't think there's really any dirt bike today that doesn't have a chain drive. So they're very, very common in dirt bikes. Sport bikes, of course, it's going to be very common, again, because of the efficiency. That 98% efficiency is going to be a huge win for sport bikes. And I'll say cost-conscious street bikes. Now, this doesn't mean only cheap, low-end bikes, but where they're trying to hit a middle ground in terms of price, they're going to focus a little bit more on using the chains because they are a little bit lower cost for manufacture, and therefore it's going to hit the price point that they're aiming for. And if you look across the vast majority of motorcycles, this is the drivetrain that is selected. So let's switch into the next type of drivetrain that you'll find on motorcycles. And this is a belt drive. And fundamentally, visually, at least from 100 feet away, it looks very similar to a chain. You're going to have a couple of pulleys at either end where the sprockets would normally have been. And instead of having a chain, you're going to have a belt that's running between them. Now, each of these pulleys, which you could think of, they're in place of the sprocket, they have these teeth, like what you have on the sprocket. They're just much smaller in terms of their stature. They're not going to be quite as tall. The other thing is that they're going to have these sort of walls on either side of the pulley into which the belt is going to fit. And this will keep the belt from rolling side to side. And the reason for that is that the belt itself doesn't have the side panels, which were actually keeping that chain from moving side to side. Those don't exist on a belt. Now, the belt is typically made of a rubber with several teeth on the inside edge. And the belt usually will have steel wires for added strength added into it. And sometimes they'll do like a Kevlar coating on the outside just to try to increase the durability of these belts. Now, the teeth of the belt will engage with the teeth of the pulleys, thus providing the ability to transfer the power. Here, the two teeth are kind of coming together, and if you were to lace your fingers together, you would almost see how your fingers are interlacing and creating that sort of gripping force. That's fundamentally what it looks like with a belt connecting with the pulleys. So what are the pros for a belt? Well, this is actually probably the bigger one when you consider compared to a chain, is they have much lower maintenance. You don't need to add in lube because it's a rubber connecting against metal. So there's already a little bit of flex that's going on there. The only thing you need to check for is stretch, because the belt being rubber can stretch over time, although with the metal strands and wires added into it, it tends not to stretch that dramatically. You're also looking for any cracks that might be in the belt or missing teeth. Because it's that rubber on the belt and then the pulleys are still steel, it's going to be a little bit quieter than what you would get with a chain, and then there's less vibration. So it is a quieter drivetrain overall compared to a chain drive. The other thing is that they'll have a longer lifespan. It's typically going to be anywhere from 60,000 to 100,000 miles with a belt drive. So lower maintenance and much longer longevity, they kind of give you a really big benefit over chains. There are some cons to it though. There are a higher cost, both upfront and for replacement. The belts themselves will be much more expensive than a relative comparative chain. They have a much higher power loss compared to chains. So you're really not going to see these on sport bikes because of that power loss. And because they're less common than chains, replacement parts might be a little bit harder to find everywhere as compared to chains. Whereas with a chain, you don't have to go necessarily to your specific dealer to find the parts. Pretty much finding a replacement sprocket or a replacement chain, they're kind of going to be most everywhere. The only thing you have to look at is like, what is the internal diameter for where the sprocket would mount to the wheel? But most of the parts are going to be fairly interchangeable. Here with belts, because they're less common, they may not even carry belts in any sort of a local shop that you might run into. And finally, they can't really be used in dirt because that would just really quickly destroy the belt. The belt being made of rubber is going to be more prone towards wear. And if you were to get some, let's say, small pebbles or dust into there, that's going to just be so abrasive onto the belt that it would destroy it in a very short period of time. So what this means is that the typical application for a belt drive is usually going to be cruisers. This is where having long intervals for maintenance and having less of the maybe performance requirement where you don't need the absolute amount of power efficiency that you would get in, let's say, like a sport bike, isn't as important. A lot of people who are riding on cruisers, they already don't have a very high performance engine to begin with. They will have a lot of torque, but not a lot of horsepower. They're not high revving. And that just has to do with the design of the engine. They may be riding thousands of miles a year on that cruiser, kind of going along on a highway, let's say. So having a belt that doesn't require a lot of maintenance, it's going to last a long time. This is an advantage, and that's why you'll find them fairly commonly onto cruisers. So next, let's talk about shaft drives. A shaft drive is most similar to the drivetrain in a rear-wheel drive car. You can think of that there's a drive shaft, which has sort of universal joints that's running from the transmission to the rear wheels. Now, the rotation of the shaft is 90 degrees to the side of what a chain would be. So the transmission output naturally has to be different. And at the rear wheel, there's a bevel gear, which switches that rotation 90 degrees to allow it to turn the wheel in line with the bike. Now, most bikes have the transmission output match the orientation of the crankshaft. Therefore, the drivetrain is going to fit better for a belt or a chain. You have to effectively rotate the drivetrain or let's say the transmission and the engine effectively 90 degrees to get it to work properly with a drive shaft. Now, the drive shaft is typically enclosed in a supporting tube, which allows it to be lubricated in a closed system with no opportunity for dirt or other contaminants to affect it. Now, the pros for a drive shaft is typically there's no maintenance required at all. It's at least from the consumer's perspective. They have a very, very long durability, oftentimes the lifetime of the bike. If you want a set it and forget it sort of an approach, these work insanely, insanely well. That makes them really awesome for touring. But surprisingly, and this is the one that sort of throws it off a little bit, they're actually pretty decent for off-road, which is why you'll see them on some of the ADV bikes, because you have it fully enclosed. So dirt and contaminants isn't going to be a problem for a drive shaft. And you have very low chance of failure or breakdowns, like snapping a chain or a belt, that are going to be a little bit more common, more possible to happen on some of the other drivetrains that we've discussed. But there is a few cons to these. The first one is they are the most expensive option. When you think of it, adding in a drive shaft and adding in that tube that is containing the drive shaft, all the oil that is going to be bathing that drive shaft, this adds a lot of complexity and therefore cost to your purchase price of the motorcycle. And therefore, they're not going to be something that you'll find on the lower cost or mid cost type of bike options. They're really going to be the more expensive type of motorcycles that will be where the pricing makes sense to invest in having a shaft drive. Now, that also means that there is, if you were to have a failure, the cost to replace the drive shaft would be, of course, significantly higher than replacing a chain or a belt would be. The other problem is that they add a lot more weight to the motorcycle, both overall to the bike, but also the rotating mass. If you think of it, I now have that tube that is holding the drive shaft is now running back from the transmission to the rear wheel. I also have the weight of the drive shaft itself inside of that tube. Well, that has a lot of rotating mass. So this is slowing down the performance and the transmission of power from the transmission to the rear wheel. And in fact, the power loss can be as high as 25%. We thought of it's only about a 2% loss for a chain drive. Well, here you've got a 25% loss. Therefore, sport bikes are very unlikely to use a shaft drive. So what are the typical applications for where you'd see a drivetrain that's a drive shaft being used? Well, most commonly, these are going to be touring bikes, which will do a lot of miles. This is where a drive shaft actually works really, really well. And in juxtaposition to the belt drive that we just discussed, which are used on cruisers, which a lot of cruisers are used for touring, the shaft drive is going to be even better because your longevity of it is just significantly longer than what you would get out of a belt. And you don't have to check for any of the cracks and stuff like that. It's effectively, from the consumer's point of view, it's really a no maintenance issue. Now, the engine, as I mentioned, has to have the crankshaft in line with the bike. And this is just to get the rotation of that transmission output to match the drive shaft, and then goes to the bevel gear at the rear, and then it's rotated 90 degrees again to connect into the wheel. So what you'll see is bikes like BMW with their boxer engine and Ural's boxer engine, both of those will make sense because the cylinders are running 90 degrees to either side of the movement of the motorcycle, and therefore the crankshaft is running in line with the bike. You'll also see this on the boxer that's used in the Honda Goldwing. Another bike that you'll see pretty common with this is Moto Guzzi. Moto Guzzi, of course, has the V-twin, but it is rotated 90 degrees. Sometimes they call this transverse. So each cylinder is sticking out of the sides of the bike. Therefore, the crankshaft is running in line with the motorcycle, and therefore they'll use a shaft drive to move it to the back. Now, a Moto Guzzi, let's be honest, it's not a high performance motorcycle. It is not necessarily all a touring motorcycle, nor is it actually, quite honestly, a expensive motorcycle. But what they chose in their world was a V-twin flipped that 90 degrees from, let's say, the classic cruiser V-twin orientation is better for cooling. You actually have both cylinders are hitting into the airflow. You don't have that rear cylinder being hidden by the front cylinder that you get in a traditional cruiser V-twin outfit. And so there were some benefits for doing so. But because of the packaging now, they couldn't use a chain or a belt drive. Therefore, they use a drive shaft. Now, there are a couple of other models that you'll find from other manufacturers. Typically, like Triumph will also have a few of these. They'll have them on the Rocket 3 will have a drive shaft. So even though it is a very high performance bike, I wouldn't call it a sport bike, but it is very high performance because it is a huge 2500cc engine. Something like 180 horsepower, I think, is the current version of that. So it's a lot of power, but it's also a heavy bike. So it's more of a muscle cruiser would be sort of the style that they have there. But to ease in terms of the packaging that was necessary for fitting in that huge 3-cylinder engine, they couldn't have that running to the side. Therefore, it's running in line with the bike, and therefore a drive shaft made more sense. The other ones that you'll see is some of the Tiger ADV bikes from Triumph will also use a shaft drive. And this is probably to make a little bit a competitive offering, let's say, to BMW's GS line, which is probably the most popular big adventure touring motorcycle that you'll see out there. This is the image that people think, is they think of a drive shaft as being part of that ADV view, at least for the big bikes. So I think that's why Triumph kind of does this. So those are the three major drivetrains that you'll find in motorcycles. But there is another one, which is sort of a special case that doesn't exactly fit these normal drivetrains for motorcycles. And this is where the transmission is mounted on the swing arm, and thus the output of the transmission is connected directly to the rear wheel. Now, in most cases, this transmission is actually a CVT, or constant velocity transmission. Internally, it would be more similar to a belt drive, with the belt running from the input at where the crankshaft would have been, and the output at the wheel. The difference is that instead of having a fixed pulley that is a certain size both at the front and at the rear, there's actually these two cones, and the position of the belt on the cone can be adjusted. And what this effectively gives you is infinite number of ratios between that front diameter and the rear diameter. Therefore, that's why they call it a constant velocity transmission, is the engine is kept at a constant velocity, usually right at its peak power band, and the transmission ratio is shifted to effectively allow you to increase your speed. Now, the pros, of course, are that CVT allows the engine to operate at peak RPM all of the time, and this gives it the maximum efficiency. Now, it's often paired with a centrifugal clutch, so new riders don't really have to use a clutch lever to engage or disengage the drivetrain. The cons, of course, are that this design has a very high unsprung mass, as it's on the swing arm, and it's going to typically be heavier than a drive shaft would be because it's your entire transmission is now part of that. Because of that design, it also can't really handle very high power output. So you're not going to put a high torque or a high horsepower engine and then have a CVT with it. It could also have a little bit of a drone of the engine because there's no real like engine rev and shifting with a CVT. It's just sort of this monotonous drone that keeps going. It's very efficient. It feels odd if you're used to a normal type of a drivetrain, especially on a motorcycle. And so the typical application that you'll see this in is in scooters. And in a scooter, of course, there tend to be fairly small engines, usually under typically 600 cc's is usually about where they max out for some of the maxi scooters. But most of them are going to be 300 cc or smaller. Therefore, they don't have a lot of engine output power. So for example, my Vespa GTS 300, which is the quote unquote big Vespa, it's 297 cc's. I think its peak horsepower is 22 horsepower. It is not shaking the world in terms of any sort of performance on it whatsoever, but it is incredibly efficient. So I average about 70 miles a gallon with that particular setup. So definitely the most fuel efficient bike in the garage and most fuel efficient vehicle in the garage, bar none. So it is a special case, but I did want to highlight this as another type of drivetrain that you will find on motorcycles. So we covered the three major types of drivetrains on motorcycles, from the most common chain drive to the belt drive found on cruisers and the shaft drive found on many BMWs and other touring bikes. And finally, we covered the special case of some scooters with the transmission also being the drivetrain. So my question is, what kind of drivetrain does your motorcycle use? Share your thoughts through the text the show link in the show notes, or leave us a voicemail at throttleandroast.com/voicemail. Thanks for listening. I'll talk to you next week. Hey, if you enjoyed this episode, please tell a friend about the show. You can often share an episode directly from your podcast app, or you can direct them to throttleandroast.com. Word of mouth is the best way for us to grow and find new listeners, so I really appreciate your help.